What if you could make it rain on demand? It sounds like something out of mythology or science fiction, but for nearly 80 years, humanity has been attempting to do just that. We're talking about the deliberate design of rainfall, a practice known as cloud seeding. It's a bold attempt to intervene in the atmosphere's most vital processes, coaxing rain from clouds that are holding back. From drought-stricken farms to smog-filled cities, the power to summon rain is an incredible lure. But the science, the results, and the consequences are all subjects of intense debate. So how did we learn to weave the weather? And does it actually work? The story of cloud seeding begins in the optimistic, post-World War II era of scientific breakthroughs. In July 1946, at a General Electric lab in New York, a scientist named Vincent Schaefer was researching aircraft icing. He was using a deep freezer box to create a supercooled cloud, which is a cloud full of water droplets that are below freezing but haven't yet turned to ice. Frustrated that his freezer wasn't cold enough, he tossed in a block of dry ice, which is solid carbon dioxide. Instantly, the air in the freezer filled with millions of tiny ice crystals. Schaefer had accidentally demonstrated a theory from the 1930s that to get precipitation from cold clouds, you need both supercooled water and ice crystals coexisting. The ice crystals act as seeds for snowflakes to grow. Schaefer's colleague, the brilliant chemist Dr. Bernard Vonnegut, took this a step further. He searched for a substance with a crystal structure almost identical to ice, so it could trick water droplets into freezing. He found the perfect candidate, silver iodide. This discovery became the foundation of modern cloud seeding. The first field experiments were nothing short of dramatic. Later in 1946, Schaefer and his team flew a plane over the Berkshire Mountains in Massachusetts and dropped 6 pounds of dry ice into a cloud. Within minutes, it began to snow. The world took notice. Australia's scientific research organization, the CSIRO, was one of the first to jump on board, running its own trials in the late 1940s. The United States military also saw the potential, leading to one of the most controversial uses of the technology, Operation Popeye. During the Vietnam War, the U.S. military secretly seeded clouds over the Ho Chi Minh Trail to extend the monsoon season, hoping to turn the supply route into an impassable sea of mud. In the decades since, cloud seeding has been adopted in over 50 countries, each with their own reasons, from fighting water scarcity to ensuring a sunny day for a national celebration. So how does it actually work? At its core, cloud seeding doesn't create clouds from a clear blue sky. It enhances a cloud's natural ability to produce rain or snow. It's about improving the efficiency of existing clouds that are full of moisture but just aren't producing precipitation. For it to work, the conditions have to be just right. You need the right type of cloud, with enough moisture and thickness. Inside a cloud, countless tiny water droplets are so light they just float on air currents. For it to rain, these droplets need to grow large and heavy enough to fall. Cloud seeding gives this process a kickstart by introducing artificial particles, called nuclei, into the cloud. The most common seeding agents are silver iodide, potassium iodide, dry ice, and various types of salt. The specific method depends entirely on the type of cloud you're targeting. There are 3 main techniques. The first and most common is called static cloud seeding. This is used on cold clouds, the ones containing that supercooled water Schaefer was studying. An aircraft releases a seeding agent like silver iodide into the cloud. Because silver iodide's crystal structure is so similar to ice, the supercooled water droplets are tricked. They freeze onto the silver iodide particles, forming ice crystals. These new ice crystals then become magnets for more water vapor, growing and growing until they're heavy enough to fall as snow. If they melt on the way down, they become rain. The goal is to add just the right amount of these artificial ice nuclei to maximize the cloud's output. The second method is dynamic cloud seeding. This is a more aggressive approach. The goal here is to make the cloud itself more powerful. When supercooled water freezes, it releases a small amount of heat, called latent heat. Dynamic seeding dumps a large amount of seeding material into the cloud to cause a lot of freezing all at once. This release of heat makes the air inside the cloud warmer and more buoyant, strengthening the updrafts. Stronger updrafts suck more moisture up from below, causing the cloud to grow taller and process more water, leading to heavier rainfall. It's a more complex and less predictable method, a bit like trying to supercharge a storm. Finally, there is hygroscopic cloud seeding. This technique is for warm clouds, where the temperature is above freezing. Here, you can't rely on creating ice. Instead, the process is about collision and coalescence. Seeding planes disperse hygroscopic or water-attracting materials like salt flares into the base of the cloud. These salt particles act like giant condensation nuclei. They greedily attract water vapor, forming droplets that are much larger than the ones that formed naturally. Because they're bigger, they fall faster and are more likely to collide with and sweep up smaller droplets on their way down, growing even bigger until they fall as rain. Bringing rain on demand requires more than just a plane and some chemicals. It's a high-tech operation. Aircraft are the most common delivery method, equipped with special flares on their wings or racks that drop ejectable flares directly into the target zone of a cloud. In mountainous regions, ground-based generators are often used. These are essentially specialized burners that release silver iodide smoke from high-altitude locations, letting the prevailing winds carry the particles up into the clouds. It's cheaper but far less precise. Some countries, like China, even use rockets and artillery shells to shoot seeding agents into clouds quickly. None of this can happen without pinpoint forecasting. Meteorologists use a suite of tools, satellite imagery, radar data, and complex computer models to find clouds with just the right characteristics for seeding. And after the mission, they use that same radar to track the cloud's development and try to assess how effective the seeding was. The technology is also getting smarter. Researchers are exploring drones as a cheaper, more agile way to deliver seeding agents. There's even experimental work with high-powered lasers to create plasma channels in the air, which could potentially trigger ice crystal formation without any chemicals. And of course, artificial intelligence is being used to create better weather models, improving the accuracy of when and where to seed. While making it rain to end a drought is the most obvious application, cloud seeding is used for much more. In arid regions like the western United States, a primary goal is increasing winter snowpack in the mountains. This snowpack acts as a natural reservoir, melting in the spring and summer to feed rivers and refill man-made reservoirs. The Turlock Irrigation District in California, for example, estimates its long-running program generates up to 90,000 extra acre-feet of water each year. That's enough water to supply nearly 200,000 households. Another major application is hail suppression. Hailstorms cause billions of dollars in damage to crops and property. Here, the strategy is counterintuitive. Instead of trying to stop the hail, you make more of it. By seeding a developing thunderstorm with a huge number of ice nuclei, the available supercooled water gets spread out among many more particles. This creates a large quantity of small, slushy hailstones instead of a few large, destructive ones. The smaller stones often melt before they even hit the ground. Cloud seeding is also used to disperse fog at airports, where supercooled fog can ground flights for hours. Seeding with dry ice can cause the fog's water droplets to freeze and fall out as tiny ice crystals, clearing visibility. And in heavily polluted cities like Delhi and Beijing, authorities have used cloud seeding to induce rain as a way to literally